Swayam Prabha. Digital India. Educated India.
Welcome back, students. We are in the module 4 of the course Fire Safety in Buildings. In the previous 3 modules, we have gone for the introduction and then into the various materials and its behavior, the standard fire test. In the previous last module, we had discussed on the passive measures which a building requires for its safety purposes. Now, today we will move on to the smoke propagation in building. As I have already told in some point that with fire, the most disturbing or the most dangerous part is the smoke, and the smoke moves into the various parts of the building quite fast, whereas the fire can be controlled within a place. So, smoke propagation in building and how to control it within the building envelope, the stack effect and the wind effect. Obviously, the smoke is carried to various levels of the building, maybe from inside or from outside, and hence how to rescue the people in case of a fire, because smoke can engulf the building, take in the building inmates, and they may be into a very problematic or a unsafe situation. So, the concept of pressurization, which is also a term which can be explained as a mechanical ventilation, we can control by that measure. We will discuss on that, and also we will discuss lastly as the smoke curtains, how you can actually keep the smoke within a limited space. Like in case of fire, with the building material typology, we can contain the fire within a compartment. Can we control or keep the smoke within a compartment? So, last is the smoke curtain part. So, let us begin with what is smoke. So, it is a plume, that means a huge mass produced when fire gets sufficient oxygen. So, it is the unburnt part of the material, it is the reactions that is happening, the fumes are generated, and it is to control the smoke is the key phenomena of fire safety, as I told you just now. What is the composition? It is mostly carbon dioxide, carbon monoxide, which both are very unhealthy to our body when it is a cellulosic fire, and also hydrocarbons are liberated when it is from petroleum or hydrocarbon related burning. So, the situations may be different. However, when it is building and it is cellulosic fire, it is the black part is the soot along with the dark gray colored gases coming out. It also contains some small floating materials which may be some unburned splinters, etc., condensed matter, and it is mixed with air. So, it is basically air mixed with so many other gases which are discharged, as which is a part of the chemical reactions of the material on fire. So, what is the smoke characteristics? It moves up because of buoyancy, because it is lighter than air, it floats up and it forms a reverse conical shape. If you see, it forms a reverse conical shape. So, if there is a fire, the smoke will go up, it will reach the ceiling and it will form a reverse conical shape. So, the smoke is moving up this way. So, this is the ground level, this is the fire, this is how the smoke is moving up, and after it hits the ceiling, it starts floating in the ceiling part and gradually it comes down. So, till it is in the ceiling part, it takes few seconds and it gradually spreads on the sides and also comes down. If we take the speed of smoke, you can see it is written smoke progresses almost 1 meter per second. Why this is given? time you have to understand, say a room is 3 meter by 3 meter, something is on fire, within few seconds the smoke will travel from that room outside if it is not contained. So, let us see some pictures how it moves. So, you see here it is developed from a journal paper. You see here there is a plume of fire, there is a fire sheet of fire on side of a sofa, and gradually the smoke with the splinters, all these black dots are splinters, is moving up, see the arrowhead, and gradually it fills in the space, that means its boundaries, that means the vertical walls, and then it gradually again comes down. Also you can see if there is some opening along a door. So, if there is a door, the smoke spills out into the space just outside it, and you see gradually after moving up it is coming down and the whole room is filled up. So, the fire remains maybe at that corner, but in few seconds the room is set on smoke, and that is why smoke is so dangerous than the fire. So, if we just see in the plan what has happened in this room, this is the point where the sofa is, and this is the point where the fire has happened, and you see there may be a window, may not be a window, and there may be a door opened or may be closed. So, the smoke will be generated and it will try to move outside towards outside the building or inside the building, because you cannot stop the smoke movement. So, till the door is closed, the leakage will be there, but gradually if there is a opening, it will come out. So, in this picture you can see the leakage has happened and gradually the smoke is coming out of the room or the enclosure where the fire has happened, though the fire is remaining there. Now, if you can let us see some plans. We as architects, we have to know how it affects our building. Say first picture, this picture is that of a hotel floor plan. Here you see in the back of the door, where this is room number 221, you can see it is written. So, here there is a plan that where I am, where you are in the hotel, and what is your exit plan. See, there is an emergency exit plan written on the picture, and you see the corridors are there which are highlighted, taking all the people to the escape route, that is the 2 staircases. Now, in case of fire, generally we do not use the lift, though in the passive method we had seen that we have a fire lift, we keep a provision of a fire lift under certain height condition and certain depth condition. So, now you can see that if the fire leaks from any of the room, it is the corridor which gets first polluted. So, corridors are the connecting places through which people will take access to the staircase. Now, this is case of a hotel. Let us see this as in an office floor plan. Here there are multiple places through which the fire exit staircase is provided. You can see here is a fire exit staircase, here is a fire exit staircase, here is a fire exit staircase. So, the building is zoned into say 1, 2 and 3. So, this may be 1, this may be 2, this may be 3. So, in case of fire in this part, people will rush to this staircase or this staircase. In case of fire in this part, people will rush to other 2, and if it is happening in the central, people will try to run both ways. So, the distance criterias, which are also mandatories as per the code, are maintained. This is a much larger scale building, and you can see the yellow red dot route has been highlighted in the plan, which goes through the corridor, which is actually active when there is a fire and the rescue or the or the rushing out of the people is happening through these yellow and red dot paths. Now, what do I mean by that? In case of a fire, if some indication is received, the people will try to get out of the building and get into something called an assembly point, where they can be taken off from the building or the site and taken to safer places. So, this plan has to be such that these corridors do not carry any smoke. Even the staircases which are actually getting important points of escape during fire has to be very safe from smoke, not from fire, because fire may be happening at one corner, but the smoke is spilling over into the entire building, and which can engulf the people through various service routes, as we had discussed in the previous class. Unlike these two buildings where people can come and stay, people can come for regular offices, this may be a shopping mall where people are floating, they do not come every day. So, they also do not have any orientation of the entire building, and they may not be understanding how the evacuation is taking place. So, at strategic locations, the plans are displayed and the routes are highlighted. As you can see, the person running, and they are given the route how they will be running from the various points and getting evacuated from the building, and which are these fire lifts, which are the fire exit routes. You can see here 1, 2, 3, 4, 5 and 6 points are there in case of a shopping mall. So, again comes the point, if these common areas through which, or the passages or the corridors through which the people will be rushing out are full of smoke, people cannot take their movement or carry their movement. Remember the 2 points. In case of fire, the power is closed, switched off, and with smoke visibility reduces, that is called obscurescence. So, we need to manage the smoke because it lacks visibility, because of smoke the visibility is lost, because of smoke because of fire all electrical points are extinguished. So, it is only the emergency lights giving you a direction, and the smoke even can lead to lesser visibility and you may not be able to see. So, that is why all the corridors which I have shown in the previous slide have to be kept smoke free. All the staircases which are marked as fire staircase has to be smoke free. How to do that? Now, let us look into a few more points before we move to the management of the smoke part. Obscurescence, which is lack of visibility, and it is told that with distance it is actually exponentially reducing, that means at a logarithmic scale it is reducing. So, if at a distance 0, if the visibility is I, you can see intensity at a distance x will be 100 into 1 minus I 0 by I x. That means, the intensity at a distance x will be 100 into 1 minus I 0 by I x, and because of this the optical density reduces logarithmically, and first meter distance travelled it will be halved, next it will be 1/4, next beyond that it will be 1/8, and the visibility will be very quickly sharply reducing down. Now, that means we have to one point is how to retain the fire there and to stop it, but the smoke that is coming out, you cannot control the smoke within your capacity, within the building capacity. So, we need to vent out the smoke. So, we see here a list of smoke extraction systems. From the horizontal connections, corridors through vents. If we can have vents, the smoke can be taken off through vents. So, what is a vent? In a wall, like a ventilator, if you have a ventilator, the smoke can be dragged out by some wind pressure. From room, through the windows it can come out. So, venting can be from windows. So, if the fire is there and the window is open, the smoke actually comes out of the window and people can get a clue that the building that there is a fire. But if there is no window, the corridor is the only way, or the atrium is the only way where the smoke can move. Now, you see the second important point is positive pressure venting. What is that? This is what is happening naturally due to wind flow or due to the buoyancy effect. The through openings or through vents, the smoke is moving out or into the building, into the atrium, moving from one level to another level, through staircases if it is a open kind, from one level to another level, and you cannot stop it. But positive pressure venting is a method where you can control the movement through pressurized air. So, what is that? In one closed chamber, if you have a little higher pressure, the smoke cannot enter into that, and that is how you take the opportunity of to control the spillage of smoke into that particular area and rescue the people. So, which were those paths? Those were the corridors. So, if you can maintain a positive pressure in the corridor and in the staircase, what will happen? The smoke cannot enter into that zone, rather it will restrict itself till it can gain the pressure up to the pressure which is being applied on the opposite direction. So, people escape the fire and firefighters can battle the smoke in that case. So, this positive pressure venting is very intelligently applied in various buildings, particularly public buildings, and it can be of two types which I will tell, and it can actually prevent the smoke to enter particularly the paths through which the rescue operation can be or the evacuation can be taken place. Evacuation can take place. Other than these, we have smoke barriers. Other is the passive way, that is the selection of materials. So, smoke barriers are something which will contain which will be having no gaps and containing the smoke within the area and not allowing the smoke to come out from that space to the next. Selection of material, yes, if we have appropriate material selected for the building structure, we can reduce the formation of smoke because of the burning process. So, these are the few ways we can take a control on the smoke part. That means, one is smoke, fire has happened, smoke created, it is being vented out either naturally by vents or through windows, and other is by forming pressure. Third is by putting barriers, we are trying to contain or extract the smoke in a particular zone. Other is the material selection through which the amount of smoke produced can be controlled. Now, let us see how we can as an architect, how we can take care of the spread of smoke or control the allowance of smoke in the staircase area. So, here you see entry to this, say this is the pressurized staircase space or the staircase. If you can take this as the space, and these are the annex spaces. It is, you can see this also in a little bigger picture. One is coming out from here, coming out from here, coming out from here, coming out from here. So, within this pressurized space, smoke entry has to be through this path, then through this path, then through this path, and then through this path. So, what is happening? It is one after the other, that means in series. When it is in series, it is very gradual, because leakage has to happen into this space, then leakage into this space, then leakage into this space, then leakage into this space. So, automatically this is the last point when it is getting affected by this space is getting affected at the last point when the spaces are arranged or the entries are arranged in series. When it is in parallel, like one can enter from this point, one can enter from this point, one can enter from this point and as well as this point, and can enter into this space, one can enter from this point. So, there are multiple points through which smoke leakage can affect and lead to this space. So, automatically it will be a faster process to enter this particular pressurized space to get polluted with the smoke. So, in case of parallel, we are looking into A1 plus A2 plus A3, where A is the area of the openings, because whenever the door is open, the smoke is getting in, and when it is multiple operation, it is entering from all the points. So, when things are happening in parallel, it is a summation, and getting the pressurized space polluted is faster. So, you have to remember, if you are putting a fire escape, whenever you are planning for a fire escape staircase, you have to give multiple entry to that. You open, it closes, you open, it closes. It may be you open and you can enter. If you are giving multiple access to the same space, you are actually adding up very fast, like A1, A2, A3, and you are polluting it. If it is in series, one leads to the other, to the other, to the main space, your leakage, total leakage is much less, and you see it is 1 by A1 square, which is the total. A1 square total is 1 by A1 plus 1 by A2 plus 1 by A3. So, A total, if you have only 2 openings also, A1 into A2 divided by square root over A1 plus A2, where A1 and A2 are the area of the openings. So, in case of locating fire escape staircase and in case of putting the entry and exit to a fire escape staircase, you have to be very judgmental. It is very important that if you can provide one or two lock lobbies or spaces that will not allow the smoke to enter into a lobby and then you enter into the staircase. So, that can help in reducing the movement or entry of smoke into the pressurized space, which needs to be kept free of smoke. Let us also look into another effect. Here you see in this picture, there are 3 windows of 3 different sizes. A small window of say 2 meter cross 2 meter, a little wider window 2 meter cross 3.4 meter wide, another window 2 meter high and 6.4 meter wide. So, in these 3 cases, one is the orifice or the opening size is small, one is, say this is small, this is medium and this is large. What is happening? The smoke which is coming out from this portion is coming out at a larger pressure from the smaller orifice and it is moving out of the building. In the second case, it is very close to the building, and in the third case, it is almost entering into the upper levels of the building. So, with smoke, if there is a source of fire, the fire may also travel if it can take up materials, if it starts burning materials. So, if you have a large window open, the smoke will graze the building or will catch the building along its horizontal or along its vertical, and if it is having similar opening on the top, on the upper floors, it may lead to entry to the upper, fire may lead to enter into the upper floors, because the temperature of fire at 1100 degrees centigrade, the smoke is also quite hot and it is moving up and it is gradually though cooling down, but it may lead to fire in upper floors. Now, in certain buildings, smoke travels inwards into corridors. When? Because there is a pressure plane, because outside the building there is a pressure, inside the building there is a different pressure, but with height also the pressure varies. At a general building height it may not happen, but when we are traveling, when we are taking care of high rise buildings or high rise structures, when the smoke is traveling outside, due to lower pressure, with wind, smoke direction is controlled. So, if our building height is more, then we also have to consider the neutral axis of pressure, where below which the up to neutral axis plane the smoke will travel inside, above the neutral axis plane the smoke will travel outside. So, this is the neutral axis. So, there are heights, neutral axis, beyond which the pressure outside is lower. As you know, higher you go, the pressure reduces. So, inside the building there is a different pressure than the outside. So, outside is low pressure, inside air or smoke will go out. Below the neutral axis, the air pressure outside is almost equal, and it will, with the wind direction, it will try to get in. So, wind direction controls below the neutral axis, above the neutral axis it is the smoke going outside the building. So, these kind of phenomena are very much important in case of high rise structures, and the behavior of the smoke or taming of the smoke as well as the fire becomes important when the fire is at higher floor levels. We gradually come to the concept of pressurization. Those were the opening sizes, variations, height and variation, movement of the smoke direction, but now we want to tame the smoke, we want to control the smoke, and we want to contain the smoke in some area and not to pollute the passages which are meant for the escape. And pressurization is the process which was developed in 1960s, and gradually it came into the buildings, particularly the high rise stair enclosures. It is a popular option for protecting the staircases, because staircase is the only path which remains active for the movement of the people. It is not a very difficult thing, but the system has to be operational whenever there is a fire. So, whenever there is a fire, suspecting that the smoke will gradually come out into the building parts, the pressurization system has to be started or initiated. That is the only part. Now, it prevents the smoke leakage through closed doors into staircase by injecting clean air into the stair enclosure, so that the pressure in the stair lobby is greater than the adjacent fire compartment. So, a flow of air is continuously maintained to oppose the smoke enter into the staircase portion or enter into the corridor portion. So, occupants who are most at risk, that is at the fire floor, are evacuated first. Then it is phased through where the fire has happened. The top people are rescued first, the lower people gradually comes out, means lower level people at the lower levels, they come out gradually, and the lobbies and the fire lift courts also should be pressurized to limit the smoke spread and ensure that the lift is available at all time. So, if it is a high rise building or a tall building, as I told, there is a mandate for the fire lift already. So, these lobbies, these fire lifts all should be under pressurization. So, challenges are protection from leakage of air due to movements, because whenever people are coming out from the building or taking the staircase, they are always opening the door, that means that A1 or A2 or A3, the openings which we discussed just in before 2 slides. So, they are always opening the doors and trying to come out to that staircase, through that staircase. So, the protection from leakage has to be ensured. Protection of means of escape are to be ensured. Protection of firefighting access routes are to be ensured. Property protection are to be ensured by the process of pressurization. We will try to see this represented drawing. I will show you in some time. So, this becomes a standard feature for high rise building codes. So, pressurization has to be there, and also there are two kinds of pressurization. One is when it starts, when the system is when the fire is, there is an alarm or their fire is set. Other is you continuously provide a positive pressure in the corridors and in the stairwells, which are marked as fire staircase. But yes, there is a loss of energy continuously if it is kept on positive pressure. You have to continuously have a fan to maintain that pressure inside that entire staircase shaft. So, that brings in cost efficiency of a building, but pressurization usually starts when there is a alarm, fire alarm, and the pressurization happens. So, that is a one stage pressurization, that on case of fire the switch is operated, but the 2 stage pressurization is always there is a very low positive pressure. With the alarm set, it further increases by additional power. The building, the enclosures, the fire enclosures and the corridor enclosures are further protected. Now, let us see the major objectives to evacuate the people from the building through the routes free of smoke. As I told you, mentioned just now, 1 stage pressurization, 2 stage pressurization. 1 stage is only when required during emergency, 2 stage is continuously a positive pressure is maintained inside, and during emergency further pressure is increased, air pressure is increased, and it is usually 50 Newton per meter square. How is pressurization happening? How is this integrity maintained? So, air supply to the designated closed area, that is staircase or the lift lobby or the lock lobby, has to be ensured. The air supply will be only to that area. Large fans are required for fresh air to enter into that stairwell and also into the corridors or the portions of the corridors. Leakage of air through gaps and during escape operation has to be considered during calculation. However, during the pressure calculation, however, care should be taken for proper gasketing or closing the edges. Venting of the air from unpressurized air to open air to maintain the desired pressure difference is also to be ensured. So, we will try to see this through this picture. I think we as architects, this visual will help you very much to get the feel of what I actually mean. Now, if you see, this is the staircase or the lobby. If you see this entire block, means I mean this portion is the building portion, this portion is the section. So, this is a section where you can see 1, 2, 3, 4, 5, 6, 7, 8, 9 floors, of which the 7th floor there is a case of fire. And this is the staircase part, and this is the lobby part. This is the lobby part, this is the staircase part. As you can see, the staircase is coming down. Here these are the pressure meters in pascals. You can see here is one pressure meter, here is another pressure meter. Now, here you see this is a small fan, exhaust fan, whose enlarged picture is here. So, this is the moment there is a alarm raised. Here there is a red box where there is a alarm which is raised because of fire in this particular floor, and you can see the fire may be at some corner, but the smoke is coming out. With the alarm, the people from this floor are coming out. You can see this lady has come out. So, they have pushed this door and trying to take this path to the ground level. Whenever this person is opening the door, you can see some smoke is infiltrating. The next person will come, some smoke will enter here, and each time the persons are trying to come out. So, this is the lobby where some leakage of smoke is coming in. There is another door which this lady is again pushing and going inside this staircase. So, this staircase is entirely pressurized by the air pushed in by this exhaust fan. You can see there is a vent shaft and the air is circulated inside and it is going up, and it is drawn again outside and also from the vent ducts inside the lobby spaces. So, these are to drain out the smoke, these are to drain out the additional air pressure, and you can see the smoke is from the lobby space is coming out from the rooftop. So, there these vents are taking the smoke from the upper part. Also, the pressure is maintained by the suction pressure is maintained by another fan at the top, and the entire space is controlled. Now, remember, if you keep on increasing the pressure, the person from this side who needs a rescue cannot open the door, because on the other side if it is very high pressure I cannot push it. So, every point you have a pressure meter which is maintaining a pressure of 50 Newton per millimeter square per meter square in this well staircase block, so that any person with a little exertion, with a little to after exerting, can come out to this place and they can take the exit route. So, with this actually the pressure meter functions and it allows to drain out some of the air from the suck out some of the air from the top. Along with, you can see the throw of the air in the various floors is happening, and along with this, the first is the, as I told already, the first is the rescue from the floor which is on fire, then comes this upper two floors get rescued, and automatically these people will also come out to the for their rescue, because whenever there is an alarm, the building inmates will feel unsafe and they will try to come out. So, with this understanding, I take into account that you have understood the method of pressurization. So, as architects we have to be aware, if it is a high rise building, if it is a large scale building, if it is an institutional building, we have to take support of this pressurization fans in the and the venting operation in the designated areas which may be fire escape staircases, and we have to provide the escape mechanism, a safe escape mechanism. With this we move to another small part of smoke, which is the double skin wall. In case of high rises, sometimes for energy conscious buildings we have double skin walls, and it may so happen like you have these as your floor plans and the smoke is trying to come out, but it is not, it cannot break the second wall. That means, there is one opening here, the smoke could leak, but there is another wall. So, this is the external facade, this is the internal facade or the inner skin. So, the smoke is entering into this part. Now, this can happen in double glazed wall, double glazed windows, and it can create tremendous pressure inside the cavity, which may lead to breakage, and hot smoke moves towards the outer skin, the outer glass panel might get cracked. So, if this hot air creates pressure on this external facade, this may get cracked. If it is not creating pressure, it may move up, and because it is a chamber or a shaft, the fire can also, along with smoke, the fire can also move up. So, one has to be very cautious whenever such kind of double glazing is used in a building. The closure, that means the sealing of the openings, has to be very much airtight or very much sealed, so that no smoke, no fire can escape, and the materials are also to be of that resistant to fire. Lastly, I would like to close this lecture with this important slide, which is smoke curtain. Nowadays, in modern buildings you will see smoke curtains. You can see this is the curtain like, which is dropping automatically when on sensing smoke. So, on sensing smoke, there is a just exactly like a rolling shutter is held on the top of a mounting roller. Above the false ceiling, there is a roller containing the smoke curtain, and the smoke curtain drops gradually to hold the smoke within one compartment and not allowing it to move to another part of a building. So, what is it doing? It is like a curtain dropping on sensing that there is a case of fire, that is why there is a smoke sensed by the sensor, and it is gradually closing the path, so that the smoke cannot move from one space to the other. You can see here it is hidden neatly above the ceiling line. So, above the false ceiling the curtain is there, it is pulled down. Similarly, you can see there here in this picture it demonstrates that these are the two lifts, and because the lifts can get the lift shaft can get smoke inside it through the small gaps, these are also protected by smoke curtain, indicating that people cannot escape through that route because lifts get closed down, and these are the smoke curtains which are preventing the smoke to infiltrate inside the lift lobby, lift blocks also. So, these are some of the advanced techniques which building systems are embedding to create segregation between the fire zone and the non-fire zone. Scales of buildings are changing. smoke curtain deployed vertically can control movement of smoke in through the atrium. So, if these kind of smoke curtains are insisted for buildings to stop smoke from one floor to the other or smoke movement from one window level to the other heights, these kind of curtains demonstrate a very safe mechanism for spillage of smoke from one area to the other. So, with this I think we will end this particular movement of smoke and we will move to the next module on the next class. Thank you.